and that will record the rest of this lecture. So, sorry, I just had a little technical difficulty there at the beginning because I was trying to use my laptop. I had to switch over, but we should be set now. Okay. So this course is 468, 568. I forgot to look. Are any of you all graduate students, or are we all undergrads? Well, we got to ask you. Besides that, looks like everybody's undergraduate, which is fun, which is great. Fine. Okay, so this course is a course in what we call GIS programming and automation. And I am going to use Canvas, but not as much as I do in my other courses. So you'll turn your assignments through Canvas, but other than that, most of the course content is actually available on this website called GitHub, which is a place for sharing code, computer code. It's almost like a social networking site, but only for sharing code and comments about that code and things like that. So I'm going to go to that because the syllabus is actually on that site. And so let's see. Again, I'm looking at my computer here. Let me get the URL. It's not a totally complicated URL, but okay. So it is github.com/MAPOSSUM. Like awesome. It's actually supposed to be map awesome. And then SPA. Map Awesome was actually a student project that we did in webmapping like probably 4 or 5 years ago, and it kind of turned into the username for the whole my old GitHub profile. But so this is the URL for the course content. Like I said, you'll at Canvas, you'll still have assignments and you'll still have due dates, and that's also where your grades will be displayed. But the content itself will be here. And this is, it's been a couple years since I taught this project, I taught this class. I taught it in 2015, and then I taught it again in 2017, and now in 2019. So it's not a course that we teach a lot. It's every 3 semesters usually. And so what's up here now is the course from the last time it was taught. And I am going to make some significant changes. So each week, I'll update the lecture. So I don't know, actually, the word M, in the letter M there is for meeting. So we only meet once a week. And we'll have about 12 meetings in this course. Because of the way the semester started, this course did meet the first week of school because the school started on Wednesday. And those meetings don't count the exams, so we'll still actually get together more than 12 times. So I have 12 lectures. All right. Here is the syllabus. So you can get any of the code off of GitHub. You can actually just hit this whole button right here, called download, and you'll be able to download the zip file containing the entire contents of the course as it was in 2017. But I'll be making changes. You can also download any individual file. So if you wanted to go to M1 today and you wanted to download one of these Python files, you can just right-click on it and say save link as, and it would save that as a Python file, which we'll talk about in a minute here. And then there's an outline of what's going to be discussed in every meeting. Okay, but before we get to today's meeting, let's talk about what's on the code. And what's on the code. What the course is all about. I spelled immediately wrong there. We're going to meet every Tuesday at 11:30, and the meeting time is listed in the course catalog or the online is excessive. We don't really need to meet for 6 hours. We need to meet for a little bit over 4 hours total because this is a 4-hour class, 2 and 2. Typically what will happen in this course is that we will meet for a time and I'll go over some concepts, and then that'll be the lecture portion of the course. And then I will go over an assignment. Sometimes the lecture will be building up to the assignment. In fact, a lot of times in this course, the lecture will be building up to what the assignment is going to be. And so we'll already have some code ready for that assignment. And then at the beginning especially, you'll just be making, well, not necessarily at the beginning, but in a few weeks you'll be making some modifications to that code and to complete the assignment. So that's how the course will flow. Right. All right, we're going to be using in this course this is basically a GIS course. Okay, it's still a GIS course. It's a course of geographic information systems, and it assumes that you've taken a GIS course before. So as soon as you know some basic analysis functions in GIS, and you can tackle some basic problems. It doesn't assume too many or any more complicated analysis, but sometimes we'll do an analysis that you may not be familiar with, but it'll build on other concepts. Right? So you might learn some GIS analysis techniques, but if you do, the idea is that we're teaching some of those to you too, in addition to the other concepts that we'll be teaching in the course. In addition to it being a course about geographic information systems, this is a course where we're going to rely on basically learning how to do GIS tasks using programming. Now, one of the requirements for the undergraduate course in Geographic Information Technology, GIT, or the undergraduate degree, is that you take a course from the computer science department in computer programming. We don't really specify what language you learn, but just by raising your hands, who has some experience or is taking a computer programming course? So we got 1, 2, 3, few people. That's good. That'll help you a lot. In fact, we eventually were trying to make that a prerequisite for taking this course. But there's several that happen here, and that's fine. We'll get you up to speed. Does anybody here already have some Python programming knowledge? Python is the computer programming language that we'll be teaching in this course. So we got Lois, you got some Python programming on it?
Just a little bit.
Just a little bit, right? Good. So yeah, we're gonna be using Python to automate GIS tasks. Now, I use that word automate. What does that mean? Well, it's related to the word automatic. So it's going to be used to speed up. You might have maybe in a GIS class you did something that was pretty repetitive, or maybe even in an internship or a job. You did something in GIS that was repetitive, that you did over and over and over again. Like you had to take a bunch of files and change all the projections because they weren't in the right projection and wanted to put them in a different coordinate system. Well, you might have to press a lot of buttons to do that, but you can speed that process up by writing a little computer program. Okay. You're going to hear the word script in this class a lot. We're going to write scripts. A script is nothing but a little computer program. actually, it doesn't necessarily have to be little, but usually that's what we would say. But some scripts can get pretty big, but it's a computer program that's written down. Okay. That's one of the things that we're going to be doing in this class is automating GIS tasks. And it's not just about taking 7 layers and turning their projections into a different. There are all sorts of different models required doing stuff over and over and over again. So things like modeling things temporally through time, that requires doing things over and over and over again. And then sometimes it becomes desirable to like look down at the individual points, lines, and polygons, or the individual cells that make up the data set, and perform some new analysis on it that's not readily available through any other analysis tool that already exists. Okay, so that's what we refer to maybe as customization. So the 3 reasons why we want to do this, I'm trying to go over here: automation, customization, finding a new way to do something and implementing it in the GIS system. How do we tinker with the individual tools and also with the individual data? That's one thing. And then the one in the middle there is coupling. Okay? What happens if there is already a solution for doing a particular thing, doing a particular type of analysis? For example, there are all sorts of cool ways to create charts and graphs and things like that. Well, what if we want to take our data and get it ready to use in a different program? That sort of activity is referred to as coupling. We're going to take our data, maybe get it ready to use on the web, or get it ready to use somewhere else. And that functionality doesn't exist in our GIS, or it would take a long time to press all the right buttons and get everything set up the right way. And so we write a small program to take the data and export it and get it ready for use in a different computer program. And that activity we called coupling. We usually refer to that as loose coupling if we're just getting it ready to use in another program. If we're getting it ready for another program and we actually cause that program to run as a part of our program, and we get a result and we display it all inside of GIS, we refer to that as tight coupling. So we can do both with Python. Okay. Python is installed as part of ArcGIS, but Python is not a ArcGIS product. Python is actually quickly becoming one of the biggest programming languages for tinkering and for data science and display. It's installed already by default on Linux machines, and it's installed along with a lot of software packages besides just ArcGIS. And in fact, for the first 4 weeks, we're just going to be, not 4 weeks, 3 weeks, we're just going to be becoming familiar with the programming language, and we're not going to do a whole lot of GIS operations for the first 3 or 4 weeks. Okay, for the first 3 weeks. And so that gets into a little bit of why. We're gonna talk about manipulating both raster and vector GIS data. We're gonna cover a few different concepts, and we'll tackle some examples. We'll learn how to ingest our data into Python. We'll also learn how to do geoprocessing in our GIS through Python and manipulate the data, the GIS data. As far as we already talked about, that we'll meet once a week and we'll have a lecture and laboratory assignment. So that's pretty good. Everyone here in this course, not just the graduate students, but everybody, is responsible for creating a GIS program that automates the task. And we don't have to cover everything right now, but your program has to implement some concepts. Branching and looping, we'll discuss what those mean actually in the next few weeks at the very beginning of the course. So undergraduates have to turn in a short 2-paragraph description of what their tool does. Graduate students, they have to turn in a paper along with their I'm calling it a tool. You can actually implement these things as tools right in our GIS. But you don't have to as part of the paper. They'd just be a script that runs, which we'll explain a little bit better today. I am assuming that you've taken 217 and you've already covered that or the equivalent. And we don't have a book for this course, but we do have a book for this course. That's what I should say. But it's not one that you have to buy. Okay, this is a Python programming book that is that you actually could buy if you wanted a hard copy of it. They sell it at Amazon. So here's a link to the Amazon selling or renting it. You could also buy it for just $2 more, I guess. But the entire book is open source. It's not illegal to do this. It's open source and it's available in PDF. So we're going to use this book for the first 4 weeks of the course, and then we'll to help us get familiar with Python. And then as we proceed through the course, I'll provide other materials for you. So this is the book itself. So I use this book to teach the basics of the Python computer programming language. So it'd be helpful to read ahead each week. So we're going to, yeah.
We have to find your repository through GitHub to have access to this.
To have access to what?
The syllabus with the link to like this book, for example, how yours is under your GitHub account. Like, how do I link my account to yours?
You don't actually need a GitHub account if you don't want one. That's not required. You just have to go to github.com/mathawesome/SPA and it'll get you there. Sorry, I should have been more clear about that.
Bookmarks are your friend.
What's that?
I had one for method class.
Oh, you had it for what? You had an account, yeah.
Yeah.
But you don't actually have to have an account here. You just have to go to that URL, and then yeah, you can bookmark it, and then you can go to it. You can go to it later. Good question. Any other questions?
Good.
All right. So here is the course content, and if I refer to page numbers, then I'm referring to the PDF version. I don't know if the print version Amazon sells you has the same page numbers. I don't have that. I'm just using the free version. So today we're going to go over the first 2 chapters. So you should definitely read those first 2 chapters. And then we're just going to start going a little bit quicker. So next week, we're going to cover 3 chapters. The week after, we're going to cover 3 more chapters. So that'll be 3. We're not really. We're going to cover 3 chapters. We're not going to even really do chapter 4. And then, yeah. So then yep.
Pretty much read the first 5 chapters by next week.
Right, but just go. One of the assignment today will be to do the book exercises for the first 2 chapters. So chapters 1 and 2. So yeah, but you could peruse over the other chapters and And do some of the exercises if you want to, but they're not due at the beginning of the class. The only thing that's due at the beginning of the class next week is the stuff from the first two chapters. And I'm actually not having you turn that in. Okay, so we'll go over that when we get to the lab. But for today, just make sure that you do it, and you understand the concepts. If you have trouble, obviously contact me, and we'll work through it. Here's a couple of other links. You get the general help for Python here. I find this moderately helpful, but sometimes it's more helpful to just Google things. And then there's actually a whole course here in Python that Google created that you can go look at. It's a little bit, it's got a lot of the same content that we're going to talk about at the beginning of this course, but it is smaller in set. It's not as big as the book that we're going to go over. It's kind of like a quick introduction, and it's a quick introduction because it assumes you have a little bit more computer programming experience than the book that I have over here, which doesn't assume any computer programming knowledge. All right, I messed up. Keep going. All right, so you will need. We're going to use the version of Python that's installed with ArcGIS Pro. So you need to have ArcGIS Pro installed on the computer that you're going to work from in this course. ArcGIS Pro should be installed on all the computers here and all the computers down there. But if you want to work on your own computer, then you need to have ArcGIS Pro installed. Now, for this course, this is the first time that I'm making the transition for this course to ArcGIS Pro. So, ArcGIS Desktop, ArcMap, does also install a version of Python. However, that version of Python that ArcMap installed is version 2.7. The version that ArcGIS Pro installs is 3.x. It depends on the version of Python. It doesn't really matter if it's 3.6 or 3.5 or 3.4. All those will be fine, but it does have to be 3 something. Okay, so you do need to have ArcGIS Pro installed, and in order to do the exercises from the beginning. Technically, you could go out and install Python 3 for the first few weeks of this course, but it'd be better just to have ArcGIS Pro installed on your computer. Jordan.
Is there a way, if I've already have ArcGIS Pro installed, last time I tried to open it, because I wasn't doing class the last semester,
Okay.
it said that I need to get, I guess, another code or another update to it. How would you go about doing it?
Sure, you have your computer with you?
Yes, sir, I have.
Yeah. I can help you. Does it give you that message right now?
It did last time I opened it up, but I haven't.
Yeah, but okay.
Yeah, I haven't.
Yeah.
I think it was saying that since you're not a student, they give you I think you can only use it for a school year maybe or something.
Oh, you're in now.
Well, I think whenever I tried to open it.
ArcGIS Pro is different than ArcMap. Sometimes gives you that error.
No, well, the last time I tried to do it, it did. But I guess.
I guess you're good. You're good to go now.
Let's just see if it did it. Because last time I tried to do it,
Yeah.
It's open now. Never mind.
Is there a file database within our computer where I can download it from, or do I need to go to Esri or all of that?
To download ArcGIS Pro.
Yes, sir.
I can give you a link to download ArcGIS Pro. Here.
Or for the desk computer here at the lab.
What's that?
For the computer at the lab, not my personal computer.
Oh, the computers at the lab should already have ArcGIS Pro, does it not?
I've just got 10.7 ARC math.
Do the other computers have ArcGIS Pro?
Yeah, they do.
That's good.
I mean, I can give you a link to download it, but I'm not sure you're going to be able to install it. I don't know. I think those computers are kind of locked down.
Yeah, you have to have a code now. You have to have access to download stuff.
Most of them got broken.
Do you want me to send it to you regardless? Does anybody need ArcGIS Pro? We've decided that computer that you're sitting at doesn't have it. Does anybody need it for their own computer?
I might need it for my own PC.
Okay. That's Ashley talking.
Yeah.
Okay, I'll send you.
Reminder.
Yeah, you can send me a reminder, but I'll send you a link to download and install. Most of the rest of y'all should have it from previous courses. Sorry, I can see all of you, but I don't really know who's talking. So whose computer didn't work? Are you just moving it?
Yeah, Michael's got it on his laptop he's working from, and it's on this desktop, so I'm just going to sit here and use this desktop.
Okay. Last time I was there was last year. I could log in and install things. So when I'm down there next week, I can install it on any of the other computers that you'd like me to install on.
Awesome.
So that way we'll have sure this is working. I'm already sharing content. Hopefully, I was sharing content before, but if it's not, you said you could see it, right? Okay. All right. Well, let's get into a little bit of the course itself. Then I think we've covered that pretty well. So now we're going to go on to M1 here, and this is what we're going to talk about. We already really talked about this part. This was just the outline of the first meeting. Okay. So I actually even really talked about scripting. What we mean by scripting is writing computer programs. But scripts, they usually run, usually when we say scripting, what we mean is that the computer program, when it's actually executed, there's a separate program on the computer that reads through your script and actually executes those instructions every time you run that script. That's a little bit different than some computer programs. Like when ArcGIS starts, there's actually a file, an executable file, that's already in computer code that runs, and it's called an executable. Okay. So an executable is a program that's already been what we call compiled. So we have a set of instructions that form a computer program. We're going to talk about that. That's going to be lots of what the course is talking about. A set of instructions to tell a computer what to do. That set of instructions has to be transformed. Does that make sense? Into a language that the computer understands. So we have human readable code. When I say human readable, that doesn't mean that you can necessarily read it. Okay? Human readable code, and that code gets turned into computer readable code, and then the computer executes that code. Well, a script most often means that you write the code, and then when you hit run, a separate computer program, it's called an interpreter, reads through your code, and on the fly interprets what you said and turns it into computer code, and then the computer executes it all at the same time. So it's interpreting and executing the code as it's running. Okay. So Python works like that. That's in contrast to lots of computer programs that are written and then they're compiled, they're turned into computer code, and then they're shared as compiled programs. So what that means is that to run Python, you have to have the Python interpreter loaded on your computer. The Python interpreter is, in fact, a computer program that's been written and compiled. So it is a compiled program. In fact, you can find that. You don't necessarily have to do this, but under C, it might be different on your computer, but program files or GIS, Pro, bin, Python. Let's see if I can remember. Scripts. Nope. Python. Oh, environments, ArcGIS Pro. There it is. Okay, so it's right there. So this is an application. It's an executable. If I run this, it's telling me that I have to be elevated to actually run it. Okay, so maybe we want to run through ArcGIS Pro. It doesn't care. I think you probably can't run it just directly, but I can. Geo. Yep. So when I run it, I get to the Python prompt. So I'm at the Python prompt right now because that's the Python executable right there. Every time something runs in Python, it runs from that location. Have you guys ran stuff from the command prompt before? Like if you go to CM, if you hit the Windows key and type in CMD, you'll get to the command prompt, right? Maybe at some point you've run a computer program from the command prompt before. But I could, let's see if this works. Python.exe. Oh, you have to be in quotes because there's a space. That's why I need spaces in my paths. So if I put quotes there, now it will run Python. I don't know if that'll work on your computers or not. Does that work on your computers? I mean, try it out if you want to. If you don't want to, that's totally fine. But now I'm running Python. This is Python. I'm running the computer program Python.exe, and now I can send Python commands into Python that will be interpreted and then they'll be run actually directly as soon as I type it in. So I can type in a Python command like 4 plus 6. That doesn't necessarily look like a Python command, but it is. It's also a math problem. If I press enter, it's going to run it and show me the result. Okay, is that the right result, 4 plus 6? So whoever, yeah, that's the right result. I don't know if you all can see that very well. Can you see it?
It's a little small.
It's a little bit small. What about for you on the coast?
You can see it.
It's good.
You can see it?
Hey, Dr. Ray,
Yeah.
the only way that Python is going to understand you is you have to type in the language it understands. You have to write syntax in order for it to understand it correctly, right?
Yes. Yeah, like, it's not going to understand if I write, hello, Python. How are you? Then it's going to say, invalid syntax. It didn't know what was going on. Hello, Python. That's invalid syntax. What that means is that syntax is the way you structured your command. And it's saying, I don't understand what you're trying to say. Okay? It's not understanding that part. So you have to structure your syntax to be Python syntax, valid Python syntax for it to be able to be understood. So what it's showing us here is that when it went into the interpreter, it couldn't be interpreted. When what you type in can't be interpreted, that type of error is referred to as a syntax error, and sometimes referred to as a runtime error, because as the computer program tries to run, it has an issue understanding it. Okay, so it throws that error.
It's possible that what you're saying is not in their library, they're looking it up, so you're not speaking correct English to the computer.
Right. You're not speaking correct English to the computer. You're not speaking correct Python to the computer. And in fact, the book points out that there are two different types of languages. Okay, there's natural languages we speak, which are interpreted by other human beings, and those languages can have some flexibility. You know, if you listen to Yoda speak in Star Wars, you can still understand him, even though he's not necessarily speaking English the way that we understand English. Well, most computer programs that use formal languages need to have a structure that is always the same, or structure that is defined. I guess sometimes there are multiple ways to express the same thing in formal languages, but they need to be defined, and they need to be able to be parsed. And so Python is like that, and all computer programming languages are defined like that. So one of the key words in the book is that you have two rules that have to do with syntax. One of them is that you have tokens; those are the basic elements of the language, and then you have structure. And both your tokens and your structures have to be legal and organized in the correct way. Tokens are the symbols, structure is the way that it's organized. So none of these words, hello Python, how are you, are actually, all of those characters and letters are actually useful in the Python programming language. It's just how they're organized. Okay, so let's actually reverse a little bit back up to the book, and we'll talk about what a program is. So a program itself, the whole reason that you write a program, before you even set out to write a program, you need to think about what you're doing and why you're writing a program. All programs need to have four things, basically. Well, not necessarily four things, but they. Well, let me say what they all need first. They definitely need to have an input and an output. That's the whole reason that you're creating a program. You need to think about what's going to go into your program, and then what the program is going to do is called the logic. And the logic is often things like math. The book points out things like conditional execution. If I encounter this condition, do this. If I encounter this condition, do this. Okay, that's logic. And then, as I pointed out earlier, sometimes you have repetition. You're going to do things over and over and over. And then finally, the other important thing is the output. What is your program going to do? Is it going to actually give you an answer on the screen? Or is it going to save it into a file? Or is it going to send it over some network? So programs are going to do all of those. And that's the reason that we're writing our program. So, especially after the first few weeks, once we learn better the syntax of Python, we will be always defining our program and I will give you a requirement. Your program must be able to ingest or input either a user keyboard, like something the user inputs. It might need to take a GIS file, and then your computer program must output X. And then you're going to be responsible for writing that center part, the math, the conditional executions, the repetition. You're going to be responsible for that. And at the beginning, we'll work through a lot of those together, and you'll just be responsible for finishing it off. Okay. All right. So this is the Python prompt. As I already kind of showed, the Python prompt, almost all mathematical expressions, well, all mathematical expressions are valid in Python. It might be a little bit, we might have to like find out what the right way to say something is, right? What's the symbol for minus? We all know that, right? 4 minus 2. That's 2. By the way, Python, when we do a mathematical expression, it doesn't necessarily care that you put spaces, but sometimes I like to put spaces. So either of those are valid. 4 minus 2 or 4 space minus space 2. But what about divided by? Okay, where's the divided by symbol on the computer? I don't see that.
Right next to the shift, isn't it?
Is it on the shift?
I mean, doesn't it use the backslash usually?
It does. It uses the backslash. So 4 divided by 2 is 4 divided by 2 is 2. So 4 divided by 2 is 2. Right? And 7 divided by 2 is what? 3.5. So we're executing Python. We're executing normal mathematical operations, and all mathematical operations are valid, but sometimes you might know what the symbol is for a particular mathematical operation. For example, 2 stars, so 6 with 2 stars, 2 is 6 to the second power. What is that? I mean, for those of you, we all know what powers are. What's that, Elvis? So 6 squared is another way to say that. We're not going to get into like high-level math in this course. That's all going to be add, subtract, multiply, divide. So there's several ways. Go ahead.
So you wouldn't be able to put the little up arrow to like represent power?
I think that works too.
Actually, 6 caret 2, that little symbol up there. So 6 caret 2 is 4. So in some languages, the caret is, actually, the book actually points this out, Jordan, there. So in some languages, the caret's used for exponents, but that's not in Python. So different languages use different ways to express different things. And so in Python, it's the XOR operator. It's a bitwise operator, which we will talk about, but not really today. So it does still have an answer. 6 XOR 2 returns 4.
Is it using caret as subtract?
No, it's not subtract. It's the XOR operator. If you're really curious about it.
Well, I was wondering because, like, even when I put in 10 caret 2, it gives me 8, and I'm like, I'm not sure what it's doing unless it's just subtracting 2.
Yeah, I mean, it's kind of obscure math. So basically, what it does is it converts both numbers into their bits, ones and zeros, and then does an OR statement. Yeah, it's not something that we need to really learn about in this course.
Gotcha.
So,
Carets don't exist.
all right, so that's that. All right, so in Python, every every let's see, every entity has a value, or every value has a type. I guess I should say that. In Python, every value has a type, but Python is not what we call strongly typed. Python does not actually care. I forgot who raised their hand and said they had some experience in computer programming. But if you've had some experience with computer programming, you had to, in some languages, you had to tell the computer programming language what something was before you used it. So here, when we did 7 divided by 2, Python just said, okay, that's a number. I know you're using that as a number. In fact, if you notice that 7 divided by 2 actually returned a floating point number. That, in other words, a number with a decimal place. But 7 and 2 didn't have decimal places. So anyway, the point here is that all of the things, all the variables that we're going to use are going to have a data type associated with them. And we're going to spend the next few weeks talking about different data types. We can type in here TYPE and say 7, press enter, and it tells us that 7 is an integer. So it's class int. That's the data type. That's actually another word for data type. It's more general. It is a class. Right, if we type in TYPE and we type in 7.0 and press enter, it's going to tell us that that is a floating point number. It says class float. So what's the difference between an integer and a float? You may not, you might have used that already in ArcGIS when you try to create a new field. Anybody create a field in ArcGIS? You have to specify what data type it's going to be. Is it going to store a number? And if it's going to store a number, is it going to store just a whole number, an integer? Or is it going to store a number with a decimal place? That's what a floating point number is. Python has an integer or a floating point number. That's two different data types. And they are different. But Python will automatically assume, I don't know, what's another language that you guys might have learned in another class? Just throw it out there.
C++.
C++. How did you declare a variable in C++? You don't remember?
Yeah, it was like 5 years ago.
Well, the basic programming language used to have to define what it is that you was going to use, like that x equal this or that. This equal that.
Yeah. I mean, I learned Visual Basic, so we always had to type in dim x as int or something like that.
Is that like Fortran?
What's that?
Is that like Fortran?
That was basic.
Yeah, basically.
But Python, you don't have to declare your variables. Okay. The weakness is that, as you can see here, Python will just assume that they're of a certain variable type. So if I wanted to create a variable, which we haven't talked about what variables are containers. They hold instances of a class. And they always have a type associated with them. So if I say x equals 7, what I'm doing here is I'm assigning the variable x, I'm giving it the value 7. I'm storing 7 inside of that container x, storing the number 7. I press enter, I didn't get any feedback. Nothing happened. If I want to find out what's inside x, I actually have to type another command called print and say print x. Just like type. Type and print here are both functions. A function is a little bit of code that somebody wrote And when I execute that code, I give it a input, and it has an output. In this case, it outputs to the screen the value of x. So anybody have any idea what's going to happen if I press enter here?
It's going to tell you what x is equal to.
Yes. It tells me what x is equal to. It says x is equal to 7. And
So if you wrote x plus 4, it should give you like a math expression, like it should do it?
if I type print x plus 4, is that what you're asking? It's going to give me the result. Yes.
Do you have to put print in front of it, or could you just do x plus 4? Would it know what x means?
Yes. Yep, you're right. You don't need to put print.
But you have to put print, well,
If
you
you can
have
actually,
to put the x equals something first, right?
Yeah.
yes, yeah.
To get it
If
started.
I put y plus 4,
It would know.
it's going to give me an error. Y is not defined. I don't know what y is.
So if you were to just go back and do y equals 4 and then do the same thing you just did, it would be what it should be.
Yeah, I said y equals 4, and then I said x plus y. It's going to say y. Oh yeah, it's 7 plus 4.
Yeah.
Exactly. I thought that. Okay, now also I can say the type of x. It's an integer. The type of y. It's an integer. So I can get the type of various objects. Now, we're going to learn about 3 data types for now. So we've already discussed integers, floats, and then the last one are strings. Strings have to be, you have to qualify a string using a quote. So you could say name is equal to quote George. So what this command is doing is taking the string George, and it's going to save it into the variable name. Python is case sensitive, by the way. Okay? So if I would just write name here, it's going to say name's not defined. But if I write name capitalized, it'll show George. It is case sensitive, but listen to this next part. It doesn't care whether you use double quotes or single quotes when you're defining a string. So, as long as you're consistent. So if you open with double quotes, you need to close with double quotes. If you open with single quotes, you can close with single quotes. So see, I could say name equals Lloyd, single quote. Now if I say name, print name, it's going to print Lloyd. So I can use single quotes or double quotes. Lloyd's my little brother's name, by the way. All right, George is my name. In case you didn't know, you probably know. Okay, so
I have one more question before we move on.
Yeah.
Function, so function is not necessarily like the addition and the subtraction, but it's more of the print in the type, like kind of like the information about the variable. Correct?
yeah, so add, subtract, multiply, and divide. Those are called operators. So those are operations that you're doing. And even this is actually an operator. I'm pointing right now to y equals 4. That's an operator, but it's I want to be clear that that operator is an assignment. In other words, we're assigning 4 to the variable y. We're making an assignment. It actually is different than saying, which we'll learn in a little while. If I said y equals 4, in some computer programming languages, there's not a separate way to say these two questions, or these two operators. One is y is equal to 4. In other words, you're assigning 4 to the value y. In Python, if you want to say does y equal 4, you say y equals 4, and it says true, or you say y equals 5, you say false. So double equal sign in Python is asking the question, does y equal whatever? And single equal sign is assignment. Y is equal to. So you're going to be using assignment a lot in this course. You're going to be assigning variables, and you're probably going to be asking sometimes, does something equal something? You're probably going to be using both of those. So you'll be using both of those operators. So those are operators. To get back to the question, actually, sorry. A function in Python is always going to have a parenthesis. Okay, so type is a function. Type x. So the function has parameters that go into the function. In other words, I already said that the function is kind of like a little computer program. So the input to your computer program in this case is x, and it's going to receive x, and then it's going to run the little computer program, and the result of the type computer program is that it's going to give you out a text version of what the type is, and it's going to tell you that it's an integer.
But Dr. Wade, once again, once you assign the value of 4, then you go back and ask the question of it for, you know that since your value had been assigned for, then use the correct syntax of saying equal. It says does it, and you know the answer is yes because you just assigned it that. So sometimes you're not going to know, if it's your program that you're writing, you'll know what those values are, but while you're writing, you should know what you're going to assign, so you go back and ask.
Right. Yeah, you would, I already knew what it was, but let's say I was reading in, like, I'm just talking about logical flow here. Let's say I was reading in a file that somebody collected out of the field, and they entered all their data into Excel. So I'm reading in an Excel file. And every once in a while, they might have written what the land cover was, and every once in a while they wrote unknown, like they didn't have a value. And so I wanted to read those variables in, every line by line, read in what the land cover was, and every time that the user reported unknown, I wanted to do something else. And so in that case, I might say, you know, first of all, I set up a loop. So we're not going to talk about that yet, but I set up a loop and I'm looping through every line in the file. And I'm saying, I'm going to set the land LC, I'm going to call that land cover, equal to whatever I read from the file. So LC is equal to the next line in the file. And I get that value. I don't know what that value is at that point. But if I want to know if it's unknown, the next line in my code could say, if LC equals unknown, then do something else in my code. Like I might not want to read in the latitude and longitude if I was trying to build a shapefile for all the points. Okay? So that's an example. Here, it's, yeah, you're right. It's kind of silly for me to ask 4 if it equals 4 because I already know it equals 4. But we're building the ability to eventually take a program where I might not necessarily know what the value of a variable is, but I might want to inquire and then act upon that knowledge and do something different if the value equals a certain value. See what I'm saying?
Well, can you say y equal boy? Can you use a word instead of an integer? Can you say y equal boy? And then, you know, like put any kind of data, and then you go back and say, does y equal boy? And since we haven't assigned the value of boy yet, boy isn't up there.
Yeah, so see what I just did?
Okay. Oh, yeah, I see what you're saying. Yeah, so you can use any kind of data.
You can use any data. Right, exactly. It could be a file, it could be, right now we've only covered integers, floats, and strings, but it could be all sorts of, any data. You can logically say, does this equal that? You know,
Can you search into a range, like if you're looking for a particular thing, you don't know what it is, but you don't want to just keep adding names to search for, you want to search a range, can you search within a range based on that same concept to find what you're looking for?
yeah, you're asking like if I was reading a range, so like, if I was reading a bunch of numbers and I wanted to ask if it was between 5 and 12 or something like that.
Yes.
Yeah, you could do that. Yeah, so you could say, yeah, you could do that as two logical operators. Okay, so let's just what's x still? X is 7, right? So I can say x less than 10, and then I need to know what the Python and Python syntax is for and, okay? But it's just that and, I think it's and x is greater than 4. That should be true, right? Maybe you have to go like this. Yep. Okay. So that's I just had to put parentheses around it because the order of operations. There's still an order of operations associated with Python. So right now I'm saying so I'm asking, is x less than 10 and is x greater than 4? And the answer is true, it is. So it has to fulfill both of those logical operations for it to be true in and. Does that make sense? So, I mean, that's a little bit, you know, I mean, that's not like super complicated or anything. All right. The book points out that that some of the differences between formal and natural languages that I kind of alluded to. One is ambiguity. Natural languages can have ambiguity. Formal languages do not. In fact, the best ones don't have any ambiguity associated with them. We've already noted a few cases where we have a little bit of ambiguity, like not ambiguity, but a little bit of differences. So like we can use the spaces or we don't use the spaces. I guess that's not really ambiguous. Okay. Yeah, redundancy, literacy. I'll let you guys read through that part. Okay. And then you guys can read through the syntax. I mean the things there. So this is an example. The first example at the end of the first section there, exercise 1.1. That is an example where you should do that. Okay. So in other words, you should go through that exercise and answer in a print statement. What happens if you leave out one of the parentheses or both? So you should answer those statements. You could try them. You can run them in the interpreter, or you can run them a different way that we're going to talk about here in a second. Okay. So we're going to talk about a few different ways to run Python, and your book doesn't cover all of these, but that's okay. Right? So Python can be written in any text editor. All right. Actually, I'm going to back up for a second there. Okay. It would get redundant if I had to type my whole program line by line into the Python window, right? It would defeat the whole purpose or defeat a lot of the purposes that I even discussed as part of this class, like, oh, we want to be able to do things repeatedly over and over and over again, right? Well, and I want to be able to do them fast. Well, if I have to type in the whole command every time, that's probably actually slower than hitting all the buttons in the GUI to do the right thing. Everybody know what I mean by GUI? It stands for Graphical User Interface. So the graphical user interface would be ArcGIS. So I'm going to open up ArcGIS right now just to show you something. The first place to run Python I'm going to talk about, well, that's opening. I'll show you. The first one I'm going to talk about is just using the command prompt. So I can write a program in Python. I'm going to write my program. Is Notepad installed on the computers down there, Notepad++?
Should be.
I don't see Notepad++.
But Notepad is, right?
Yeah.
Notepad++ is just a little bit cooler than Notepad. I'm just going to show you. So you could do this in Notepad too, but I'm going to think. See, I can tell it that I'm going to be typing in Python, I think. You can't do this in Notepad, but you can do it in Notepad++. I'm typing in Python. I'm going to tell it I'm typing in Python. I went to languages and then just went down to Python and clicked P. So I could type a Python code right in this window. I could type, x equals 7, b equals 6, y equals 6. It doesn't really matter. It doesn't have to be. And then I could say c equals x plus y, and then I hit print c. So now I've written a little program. It's not a very complicated program. It's not a useful program. But this program will execute. I don't have to type each line individually. That's what we're going to be working up to, is being able to do this to write more complicated programs that'll actually do something useful. Just going to see if I can make that a little. So I can write a program right in Notepad or Notepad++. The reason why I like Notepad++ a little bit is because the only thing that thing that it gets you if you hit Python is that it colors certain things, certain colors. So by default, Notepad++ colors your values red, and it colors any functions blue. Forget all the colors that it does, but it kind of gets you a flavor for what you're doing, whereas Notepad wouldn't do that.
So if you do use Notepad instead of Notepad++, does it assume what language you're speaking in? Like whether it's Python or whatever?
No, it doesn't matter. You can write, Python is just text. And so as long as you're writing it in a plain text editor, you can use any plain text editor. And so Notepad doesn't know that it's writing Python, and that's okay.
Can't you also do it in Word?
You could do it in Word, but you can't save it out as a Word document because it's a binary file format. So the computer needs to be able to read it, and it has to just contain text. So you go to File, and you go to Save As, and it'll be helpful if you save it as .py. So here I'm gonna save this under C. I'm gonna make a new folder. C. I'll call this. I'll just put it under. Don't I have a user? Yeah, George Riper. There we go. I'm gonna save this under courses, and then save it under new folder. I'll call this SPA. I'm just going to save it in there. I would normally save it also under week 1. I'm going to call this program1.py. Now, if I go to that location, where did I put it? forgot where I put that. This PC, no, it's under me. C users. Oh, it's W4968, whatever my 27. There it is. And then courses, SPA. There's my program right there. All right. Now I'm showing you a more complicated way to run this program that I'm going to show you in a second. Okay. All right. So I got my program there. If I want to go, I can open up the command CMD, Windows CMD, so I get to the command prompt, and I can type out. Okay. I could type out the whole path to the Python executable. I forgot it. It was kind of convoluted, right? So I got to go C, program files, ArcGIS, Pro, bin, Python, environments. There it is. So that's a pretty long path, right? Copy. I'm going to paste it right here, and then I have to do /python.exe, and I have to put all of that in quotes. Right? That's a lot of place to get to that Python executable. Now, if I want to run my Python script, I put a space, and I also put in all of my Python code. I mean, sorry, all of the path to my Python code, which was also really convoluted. I should have put it in a better place. Oh, there it is, right there. So now I get that full path there. Quote SPA/program1.py. So now what I'm doing at the prompt is I'm telling Python to run this script, and I'm going to press enter, and I get 13 as my answer. Okay. All right. Now, you don't have to run Python that way. I'm just showing you could. Okay. It ran Python. This line told it to run the Python executable. This part said which script to run. So if I had just run this, does everybody remember what happens? Let's review. What happens if I just press enter right now?
Well, you would go to the prompt site.
Go to the prompt, exactly. Good job. Okay. So if I want to exit it, I get back out to the command prompt, and if I type this whole thing, it's telling Python to run that script. So then it's basically interpreting that script for me. All right. Now, I'm going to show you another way, which will probably be easier for most of you. So if you already have ArcGIS installed, you can open up ArcGIS Pro, and there is a Python interpreter window right in ArcGIS Pro. You do have to wait for ArcGIS Pro to open. That's the drawback. It takes a few seconds there. Okay, so we got ArcGIS Pro open. I just selected the default without a template one because I don't even care about having a map right now. So if I wanted to add a map, I could, but I'm going to go under Analysis, under Analysis. So that's Map, Insert, Analysis, and then there's this button that says Python. Show the Python window. So if I click on that Python window, now I've got an interpreter, and I can type in things like, B equals 8, B equals 8, A equals 2, C equals A plus B, and then C, or print C equals 10. Now, in the interpreter, you can actually just type the name of a variable and show you what it was. You don't need to type print C. But if you're actually running a script and you want to see the result, you do have to type print C. Okay. So how do I actually run a script? Well, I can right-click on this area right down here, and say load code. So now, if I hit the load code, it'll give me a dialog window, and I can go to wherever I've saved my code, which I saved in I should have saved it in a better place. And then courses, SPA, program 1. Okay, so now I'm going to hit OK, and it's going to load my code in. See how it just loaded in there? And then to get it to actually run in ArcGIS's Python, I need to press Enter twice. So I press Enter once, I press Enter twice, and it'll run it, and it'll give me the answer, 13. So that's another way to get to Python's interpreter. Now, yeah, go ahead. Sorry.
So Dr. Reagan,
yeah.
Once you go into ArcGIS Pro, you want to try to get to the command prompt, which is like your Windows command prompt. Command prompt, once you get to the command prompt, then you're at the bottom of the screen. It's waiting on you to get some code.
Yeah, the command prompt is different. This is the command prompt. That's not really part of ArcGIS. It's its own program. So what you want to do is under Analysis Python to get to the Python window.
Right. Well, I'm just translating as that's like the one that's waiting on. Just like in DOS, this is waiting for me to get some instructions.
Right.
To what to do the exam.
Yep.
So you went to what that script we wrote before. Now, how did you do that? You asked it to.
I right-clicked down here and said Load Code, and then I can go and find any Python script and press Enter twice, and it'll run it.
So it asks you where the code is at, and then you determine where it's at. And once you go in there and hit that, it'll load it, but you got, in order to execute, you got to do it twice, right?
Yeah, it's press Enter twice, exactly. Yep, to actually get the interpreter to run. Now, you do make a good point, Elvis, in that what's actually happening when I run this is it's actually running this. So somewhere in the bowels of the operating system, when I hit Enter twice, it's taking that code and it's actually executing this command right here. It's executing that command, and then it's getting the result and it's putting it back on the screen. So it's just doing that for you, but it's still running the Python executable and it's returning that out to you. It's just putting it in a little bit nicer window for you. So that's another way to run it. Now, if also, I'm going to tell you two other ways. Okay, one way we're not going to do a whole lot of in this course, but it might be useful to you at some point. So there are what they call IDEs. An IDE stands for an Integrated Development Environment, and there's lots of them. I'm not going to go over all of them, but one of the more popular ones for Python is called PyCharm. Okay, so you can download PyCharm. See if they have a screenshot. Yeah, here's a screenshot. So, and you can write your Python code right in PyCharm, and it will actually symbolize it for you. Variables will be colored different colors than this case. These are function definitions. So this guy's writing his own functions, which we'll do in this course later on. And he's writing his Python script, and inside of PyCharm, you can tell it where your Python executable is, and then you can actually run your Python scripts right inside of PyCharm. Okay, so that's another way to do it if you wanted to. I have PyCharm installed on my computer, but I'm not going to install it on this computer right now. Otherwise, I would show you. I'll probably show you next week when he's gonna allow me to hook up my computer next week. So, but anyway, we don't need to do that for this computer for this week. So that's a way. There are other ones. There are very general IDEs, like Eclipse is a general IDE that I think has the ability to program in Python. But PyCharm is specific in that it's written just for Python, doing Python coding.
And you said IDE stands for Integrated Development
Environment.
Environment?
Yeah, so basically what it does is it allows you to code and execute right in the same environment. And it provides, like, as you're typing, it kind of tries to figure out what you might be trying to do. You'll notice that Python does, ArcGIS does that too. Like, if I start typing in print, oh, it tells me there's a function called print. So ArcGIS will do that as well for you. But the weakness here is that it's just line by line. Notepad won't really do that. Let me see. Well, it kind of does it. No, it doesn't really do it. It just tells you that you've typed the word print before or something. So it's not really code help. But
also too, since Python is so versatile, people program so sloppy. You're almost trying to help format and syntax lines, whatever you're doing, so it'll help you as you program. But
yeah.
everybody just write sloppy. Python becomes so flexible.
Yeah, Python is flexible. It's used a lot, so you'll be able to find a lot of help online. Yeah, one of the strengths that I like about Python is that you'll see, later today we're going to talk a lot about this a little bit more. Is that Python's pretty structured in terms of its spacing and indenting, and so it requires some of that. You'll see that as you go through. I'm going to discuss one more way to use Python that we will use a lot in this course that I haven't used a lot in previous courses. And you should all have this installed if you have ArcGIS installed. If you hit Windows and you start typing JUP, you'll see this command pop up. I mean, this program pop up that's called Jupyter Notebook. So click on Jupyter Notebook. I want to make sure this is running on all the computers. I hear some errors. Anybody get an error? I guess I haven't checked to see if this is working on this computer even. There may be this uses a local web server. Okay, it did work for me. It just took me a little while. It's using a local web server, and so there may be a firewall issue. Let's see. Does it open on y'all's computer? Do you guys see what I see right here? You don't see that? Did Jupyter Notebook even pop up?
I got a black screen that says access the notebook, open the file, browser.
What about on the coast? Do y'all have this show up?
I have different files.
That's fine. That's fine. Just do you see the Jupyter logo and some files that show up?
Oh yeah.
Okay. Everybody sees that except for you don't see it, Benjamin, still?
I'll do it if I put that into a browser.
Oh, okay. Cool. So it shows up in the browser.
Well, it gave me a code that's basically like saying an extra step, take this code, put it into a browser, and then
Okay.
now have it up on system.
Yeah, by default, it opens up in whatever browser is your default browser. So if you prefer Chrome, I'm pretty sure you can just copy this over there. Let's see, Control C. Or you could set Chrome as your default browser like I do. I have on my computer. Okay, now it's asking for a password or token. Anyway, let's just use it in our in Edge for now. All right, so I've got it open here. Okay, this is what's called interactive Python or IPython. So interactive Python is kind of like a mix between the interactive terminal and script writing. You can write pieces of your code as scripts and then execute them individually. So I'm going to create, if you go to new here, you guys can do this too if you want, new Python 3. Let's say you had multiple versions of Python installed, it would show up as different versions. Okay. We just have Python 3 installed. So I've got new Python 3. Now I've got an interactive window, and I could put Python code right here. So I could put things like, A equals 4, B equals 5, and then run that. And then I could say C equals A plus B, and run that. And then print C, and run that guy, and it'll give me the result. Or I could put all that, in the same window, and then get rid of these other cells. I've never found a delete cell. I just cut them. I use cut. These are called cells, by the way. Now I could run this cell. It's a whole script and get the answer. So we're going to be using interactive. I'm going to be using interactive Python for a lot of the examples in the course, because it's a way to keep the code organized, but still have kind of the best of both worlds between a script and the interactive terminal. Now, when we get into writing custom tools, sometimes we want to give up the entire interactive part of it. We want to just run it, and we don't really care about seeing all the individual pieces. So in a few weeks, I'll do some more just writing the code and executing it like in ArcGIS. But at the beginning here, this is a very good interactive thing. Each one of these files is called a notebook. This is called a notebook. And if I want to change the name of the notebook, I can just call this example 1 by clicking on the untitled and rename it. And it actually saves on disk. It saves to, by default, it's that same C users W496207. There we go. So here's my example 1.ipy. That stands for Interactive Python Notebook, IPYNB. So it saved it right there.
So we're going to change your
That's a good question.
our hard drive.
Yeah, well, is there a way to save it as, is what you're trying to say?
Well, because when you click file and I click file, I don't have save as like you do. Like save as,
Oh, you don't have save as.
No, mine doesn't show that.
Now, when you create a new notebook, you can create it in any directory. You have to be in your, so it will only run in your logged in directory. So this is users George, and so I can go anywhere in users George. I can go to documents, and I could create a new folder inside of documents called. I could rename it. I could rename it, Python. Whoops. I could rename it Interactive Python Notebooks. And then inside of there, I could always be creating my new Python notebooks in there. So now it put it in that directory. So that's under Documents, Interactive Python Notebooks. Now, you might be asking, well, can I put it somewhere else? No. Interactive Python, because it's actually running a little web server, as a security measure, it's not allowing you to write anywhere on the operating system. It's only letting you write to your login directory because it's running through a browser.
Under you?
No, you're logged in as whoever you're logged in as on your computer.
Oh, okay.
Like it's saving yours. Like, do you see your file or no?
Yeah.
Yeah. So yours is under users, whatever your W number is.
So I guess my question on that is, if I'm going to a different computer, and I log in, that will be able to see that file.
No, you won't. You would have to email yourself or somehow copy that interactive Python file. So if I wanted to use this on a different computer, I'd have to copy this and put it somewhere else. Does that make sense? It's still saved on your local computer only. It's not. And in this course we will discuss there is a way to do interactive Python in the cloud. Like, in other words, the file is actually on the cloud, and we'll discuss that in this course. But that's not where we are yet. Okay. So this is just like that other .py file, but now it's a interactive Python notebook file. So I've got it right here, and you just need to see where it's saving it right there. So it only runs in that directory. Now, I could see there might be a way to change the default directory for notebooks, but I don't know if it would even allow us to do that on the computer with privileges. See what I'm saying? Like, we might have to just do this in our directories. So yeah, that's where it saves it by default. And if I rename this right here, like if I rename this example 2, now it's called example 2. In my file structure, it's going to rename it example 2. That time I followed my rule where I don't like spaces in file names. So it's right there, and now it's there. This file right here is kind of convoluted. It's actually a JSON file. JSON stands for JavaScript Object Notation. It doesn't contain, well, no, it would contain the code if it was actually written out, but the code's not written. There's no code in there yet. But I wouldn't try directly editing those files anyway. I would edit them through your Jupyter Notebook. So I could type something here like print. Right, so now I've got my little print statement with what data type is this right here? Is this entity? By the way. Yeah, it's a string. Okay, I'm going to save this and then close it and close it up again. Sorry, and then I'm going to go to File, Open, and I'm going to go to, where did I save that one? I saved it under Documents, Interactive Python Notebooks, and now I can open it and I have it again. But it's only on that computer. It's only on this computer, unless I took that file, this file right here, and saved it somewhere else. I could take that file and put it on my thumb drive, take it home, then I'd have to put it back in my same directory, and then open it up again.
Hey, Dr. Ray, is this Jupyter program only for testing files? If you want to use it as you can set up pathways to Jupyter if you run the program that's going to be interactive with, let's say, program that we use in the real world. You want to just send it to a Jupyter, you want to send it directly to a Jupyter program. This is going to test the program that you write and then what you want.
So that's a good question. The interactive notebook is definitely like that. The just plain old interactive window. We never would want to write a real world program. However, Interactive Python, the Jupyter Notebooks, was actually created for the setting of being able to share code with somebody else in an interactive setting. And so it really depends on what you're trying to use it for. Like, if I'm trying to show somebody a concept of how to do something in ArcGIS, the interactive Python might be a good way to share that. If people don't really care how it works and they just want a tool that they press the button and it does what they do, yeah, the interactive Python's not really a good way to share that sort of thing. Okay? But one of the things that interactive Python does is it does allow, not all cells have to be code cells. So one thing we could do here is insert, I could go to insert a cell above, and then change this cell from a code cell. There are several different types of cells. There's headings, which is kind of self-explanatory. There's just raw text cells. And then there's markdown cells. The markdown cells are almost like raw text cells, but they allow for a little bit of formatting code to go in them. This course isn't really a course where we're going to learn Markdown, but if you want to type in Markdown, Markdown cheat sheet might be good. So this code, Markdown is a little, it's kind of like a very simple version of HTML. So I'll show you a little bit about what it does. So if I wanted to just make a bold headline, I could type in the pound sign and then space H1 and say, welcome to class. It's line by line too. So if I go to the next line, I'm not doing a bold headline. I could say, in this class, we are going to learn some stuff. And then there's all sorts of different things you can do. Like you can create an order list by doing 1, 2, 3. So I could paste that in here. Let's just 1. We're going to learn Python. 2. We're going to learn ArcGIS. And 3. We're going to learn I guess we already covered that. All right, so now if I run this, it will format according to Markdown's rules. So that's how that gets formatted. I don't know why. Maybe the rules are slightly different here, but I want to go back in and edit this. Maybe it's leaving that H in there. Maybe just 1 pound sign means a heading. And it's sufficient enough. Yeah, that's what that is. Okay. So I could also change the next line right here. Maybe just do 2 of these, and that's a subheading. No, you have to do a space. Anyway, it's kind of fun. There we go. See how that's a subheading? It's a little bit smaller than the other heading. I want to change that to a subheading. 3 of those guys. It'll be even a little bit smaller. So that gets saved in with the notebook. So if you were trying to teach somebody, which I'll actually do some of this in this class, trying to teach somebody a concept, you could have these comments inside of your code. Now you can do comments in regular code. Okay. In fact, we could go back to our Python right here, and if I typed in the pound sign, that's the comment. That's comment in Python. Pound. I type in this is just a comment. Python basically ignores that line. Even if I hit enter twice, it's just telling me that that's a comment, and I can put in comments into my code, and those are often helpful for other people to read my code later. I can put in a comment here as well. Line prints. I rerun that. I don't really have to rerun it because it produces the exact same thing. So that is that's interactive Python. Maybe you get a little bit better flavor as to why we'd want to use it. The book will, all the code that's written in the book will work in interactive Python, but the book doesn't even bring up interactive Python. It doesn't talk about it. If you're interested, let me see here. Anyway, the school, I got to find that some other time, but the school is putting on it's biology geared though. It's biology geared for, I'll bring that up. I'll bring that next week. But they're running a little tutorial on interactive Python. Okay. All right. So this is interactive Python. Why don't we take like we're only going to do one more chapter, but still I've been talking for 2 hours and maybe everybody's getting a little bit tired. But let's just take a little break, and we're only going to come back today. We're only going to meet for about a half hour after the break, but I'll go over the second chapter and we'll see if anybody has any questions. But let's take a little 10-minute break. It's 1:29 right now, and that'll also give me opportunity to break the video right here as well. The video gets pretty long. I'll do that. So go ahead and take a 10-minute break, and then we'll come back and continue on.